Okay, so finally we look at the problem in which we apply the concept in finding the probability. So in the other two videos, we were looking for areas given the z-score, and there is also an example in which you find the area given the x value, which we change to a z-score before we refer to the table. So this is now the application of the concept. Now, to give you an overview of the difference between normal distribution and the other special discrete probability distributions, take note, normal distribution is a continuous probability distribution, while the binomial, the hypergeometric, and the Poisson distributions are all based on discrete random variables, in which the variables are counted as compared to the continuous random variables which are measured. If you look at the subject of the problem, we are considering the heights of the students, and the heights or a height of a student is measured and not counted. So clearly, this is not a problem on special discrete probability distributions. Aside from that, in most cases, it will be specified if it is indeed a normal distribution, and it will say a phrase or an expression saying it is normally distributed, and that's how you know that you have to apply the concept on normal distribution. Okay, so let's answer the three questions. Given that in a certain high school, the heights of the students are normally distributed with a mean of 160 and standard deviation of 10 cm. By the way, another pattern in questions on normal distribution is that you will be given the mean and you are also given the standard deviation, and this will set you in using z is equal to x minus mu over the standard deviation sigma. You need to know the mu and you need to know the sigma, and in this problem they are given. Okay, now for these three questions, let's take a look at the differences on what are being asked or what is being asked for each. This is finding the probability that the student will be less than 158 cm. And then the other question is will be taller than 164 cm. And then the last is between 156 and 165. If you remember our examples in the previous videos, we were talking about area to the left, area to the right, and area in between. So here, these are now changed into finding probability, in which it is you no longer say to the left, but you say less than a specific number or measure. You no longer say to the right, but you say taller or greater than a specific number, in this case 164. And then you no longer say finding the area, but you want to find the probability in between two values. Okay, so let's answer number 1. So find the probability that a randomly selected student will be less than 158 cm tall. Let us create first a normal distribution showing the mean 160, and then we locate the value indicated in number 1, which is 158, and 158 should be on the left of 160. This 158 and 160 are x values in the normal distribution. To find the probability, we have to find the area to the either to the left or to the right, depending on the question. Although in this case we have to consider probability which will be less than, so that means we have to find the area to the left. So finding probability is finding the area under the curve for the standard normal distribution. So once you have the normal, you have to create a standard normal distribution, and that means 160 is now 0, and then you have to find the corresponding z-score for 158. To do that, we have z equals 158 minus 160 over the standard deviation, which is 10. So this is over 10. And this is 158 minus 160 is negative 2, and then divided by 10. Negative 2 divided by 10 is equal to 0.2, or negative 0.2. That's negative 0.20. Okay, so now that we have the z-score, we have to refer to the z table. Okay, so take negative 0.20 as negative 0.2 and 0, 0. So negative 0.2 is located here. So let's locate our negative 0.2. And then 0, 0 is here. So actually this is the first number, or the first value, 0.0228. So 0.00228. So the probability that the height of the randomly selected student is less than 150, that's 158, is equal to 2.28%, or 0.0228. Okay, so that's how you answer probabilities involving normal distribution. Okay, let's look at the second problem. Find the probability that a randomly selected student will be taller than 164. So taller signifies finding the area to the right. Okay, so we continue, or we do this by considering now x is equal to 164. First, we have to find the z, which is 164, minus the mean, which is 160, divided by the standard deviation, 10. This will be equal to 4 over 10, and 4 over 10 is 0.4. Again, once we have the z, we have to refer to the z table. Since the z-score is a positive number, then we have to use the portion of the z table in which we have the positive z-scores. So 0.4 should be taken as 0.4, the number on the left, or the first column, and 0.00 on the first row. And the area to the left of the z-score is 0.6554. So the area is equal to 0.6554. Now from here, you have to take note that the probability that we want is that the selectively, or the randomly selected student, has a height higher than 164, because it says taller than 164. Now since this is the area to the left, and we want to find or consider the height taller than 164, then we have to find the area to the right of the z-score 0.4, and that is simply by subtracting the one you obtain, 0.0 or 0.6554, you have to subtract this from 1 to get the area to the right. And 1 minus 0.6554 is equal to, this is equal to 0.3446. Again, you can always use your calculator to compute for the difference. So this is now the probability that we want. The area is the value of the probability. So the probability that the student will have a height, that's your x, greater than 164 is equal to 34.46%. The chance of that student having a height higher than 164 is 34.46%. Now take note, if the question was the height, the probability that the height will be less than 164, then we could have simply answered it as 65.54%. So always check the probability being asked. Is it the probability that will require you to take the area to the left or to the right of a z-score? Okay, finally, we look at the last task, which is finding the probability that the student will have a height in between two given values, 156 and 165. So we're looking for the probability that the height x is between 156 and 165. Okay, so all we have to do is to repeat the process and take this as if this is a simple question on finding the area in between two x values. Okay, so you can start with a larger number. So take x equals 165. Use the z formula to find the z-score for 165. So that's x 165 minus the mean 160 over the standard deviation 10. And this is equal to 5 over 10 or 0.5. The area to the left of 0.5 is taken, so this is 0, if this is 1, this is 0.5. The area that we are considering is the area to the left of 0.5, and we can find that area by using the table. So for 0.5, that's 0.5 on the first column and 0, 0 for the first row, and the area corresponding for 0.5 or to 0.5 is 0.6915. So this area is 0.6915. Okay, now we have to consider the other x value, 156. And that means we have to find the z when x is 156, then minus 160 divided by the standard deviation equal to 10. 156 minus 160 is negative 4 divided by 10, and this is negative 0.4. Again, you have to refer to the z table by using z equals negative 0.4. So for negative 0.4, that's negative 0.4 and 0, 0. So the area is simply 0.344. So area, again, 0.3446. So in our graph, if we have z equals negative 0.4, that means, so let's locate that z. So 0.4, let's say, is somewhere here, negative 0.4, the 3 or 0.3446 is this red area. and the area that we want is this. Okay, so to finally find the area in between, we have to subtract the 0.3446 from the bigger area, 0.6915. So 0.6915 minus 0.3446 is equal to 0.3469. And that's 0.3469. So the probability that the height is between 156 and 165 is equal to that value in percent, 34.69%. Okay, so that's how you find the probability for a normal distribution. So there are several steps that we have to consider, we have to perform. That is, with the x values given those heights like 158, 164, 156, and 165. These are all x values. So we have to change them first into their corresponding z, and then once we have the z, we have to refer to the z table to find the corresponding probability. Okay, there are three main questions in finding the probability. That is, having less than, having greater than, in this case taller than a number or a height, and then probability in between two values. Okay, one possible question that could be unusual is finding the height or finding the probability that a randomly selected student will have a height equal to. So I need you to take note of this. If you are given a continuous probability distribution and they ask you for a probability in which it says equal to a specific number, so this is 158, for example, 158. Okay, in the continuous probability distribution, it is highly dependent on an area. So setting a value equal to, or setting an x equal to a certain number will just make it, so if we go back to the graph, it will just get or give you the line at 158. So there is no area that you can find if you're just given a line. So to answer the question, what is the probability that the height of the student will be equal to 158, then you simply say the probability is equal to 0. Okay, so you can only answer, or you can only have probabilities or non-zero probabilities when it talks about less than a number, higher than a number, or in between. For continuous probability distribution, a probability of x equal to a certain number will be 0. If this is a discrete probability distribution, then that's how we exactly find probability. We consider an x equal to a given number. Okay, so I hope you were able to understand the ideas behind the normal distribution and how to answer problems related to it. Okay, again, it is always very important to keep in mind that before you perform or use this formula, you have to check first if the distribution is a normal distribution, because you might be using the concepts of discrete probability distribution on a normal distribution, which is different. Okay, that's a different set of concepts, and the computation is also different. Okay, so to check your understanding, I need you to copy this problem and try to answer using the ideas that I discuss in all the videos. Okay, if you want more examples or exercises, you can also try this. Number 2, you can pause the video if you want to copy the question, and also number 3 here, and then number 4, and then number 5. Okay, so these are different problems, but you don't need to do all at the same time or the same day. So maybe what you can do is to start with number 1, then if you want more practice, you do number 2, you want more, number 3, and so on. Okay, so that's all for the normal distribution.